Chapter 5.7 is matrices. A matrix is a rectangular array of numbers enclosed in brackets, and it's really important to use the brackets, right? That specifically means it's a matrix. If you just put a straight line, that's going to mean something else that we'll see in the next section. Matrices are described by their dimensions. The number of rows is always given first. So for example, this matrix has 3 rows and 2 columns. This would be a 3 by 2 matrix. This matrix has 2 rows but 3 columns. So this is a 2 by 3 matrix. Of course, this one has 2 rows and 2 columns, so a 2 by 2 matrix. This one is also a 3 by 2, and both of these are 2 by 2. Okay, so it's row by column. To add or subtract matrices, the matrices must be the same dimension. So because both of these are 2 by 2, I could add these. Both of these are 3 by 2, I could subtract this matrix from this matrix. But because these have different dimensions, I could not combine these matrices either using addition or subtraction. So we'll just say not possible. If you want to use the symbol for the empty set, I guess technically that's fine. But it's not possible to add these matrices. If your matrices are the same dimension, then of course your answer will be a matrix of that dimension, and all you do is either add or subtract the elements in each position. So here I'd have 9 plus -3, and that would go in the same position. 4 plus 2, -8 plus -4, and 2 plus 7. Adding or subtracting matrices is just combining each element of each matrix and with an element in the same position, and then listing it in that position in your answer matrix. 4k minus k, 3k, 8y minus -y, 8y plus y, 9y, 6z minus 2z, 4z, 5x minus x, 4x, 2k minus -k, so again 2k plus k, and 4k minus 6k, -2k. Adding or subtracting matrices. To multiply a matrix by a scalar, or in other words, a single numerical value, all I do is distribute the scalar to every element in the matrix. So now this is a scalar times a matrix. I just multiply this -3 by every element. -3 times 2, -6, -3 times 3, -9, -3 times 5, -15, -3 times -1, +3. To multiply two matrices together, the number of columns of the first matrix must be the same as the number of rows of the second matrix. So, for example, this is a 2 by 3 matrix, and this is a 3 by 2. So what has to happen is these have to be the same number. Because they are, that means I could it's possible to multiply these matrices. Not only that, my answer will be a 2 by 2 matrix. Down here, I have a 2 by 3 and another 2 by 3 because these columns are not the same as these rows. This is not possible to multiply these two matrices. To multiply two matrices, the number of columns in the first matrix has to be the same as the number of rows in the second matrix. And then your answer matrix will be the same number of rows as in the first matrix, columns in the second. So I can expect to get a 2 by 2 out of multiplying these two matrices. Now, to do the multiplication, I am going to multiply row by column, row by column. So first of all, I'm going to take this row and multiply it by this column. So row 1 times column 1. And I'm going to put that answer in the row 1, column 1 position. So this will be negative 3 times negative 6. 18 plus 4 times 2, 8, plus 2 times 3, 6. Right? So I'll multiply every element in the first row by every element in the first column. All right. Now I'm going to multiply the first row by the second column. And I'm going to put it in first row, second column. Negative 3 times 4, negative 12. Plus 4 times 3, 12. Plus 2 times negative 2, negative 4. Okay, once I've multiplied this row by every column, so if there was another column, I would just continue. So first row by every column, then I move to the second row. And I'm going to multiply the second row by every column. So first, I've got second row times the first column. And it's going to go in the position of the second row, first column. 5 times negative 6, negative 30, plus 0 times 2 is 0, plus 4 times 3 is 12. Okay, now I'm going to multiply the second row by the second column and put it in the position, second row, second column. 5 times 4 is 20, 0 times 3 is 0, and 4 times negative 2 is negative 8, which gives me 18 plus 8 is 26, plus 6 is 32. Well, negative 12 plus 12 plus negative 4 is negative 4. Negative 30 plus 12 is negative 18. And 20 plus negative 8 is 12. There's my answer. And notice it is a 2 by 2, exactly what I expected to get. So multiplying two matrices, first I check the dimensions and make sure it's possible. And then I simply multiply each row by each column. Okay.